All right, so another super quick hint for problem 31 on Gauss's law. So in this problem, we have a cylindrical symmetry, and it's a little bit different from the problems that we had in class where we always had a three-dimensional charge density. Here we have two cases. We have a long, thin wire, which is given a linear charge density, right? So the units here are going to be coulombs per meter. And then we have what I would call like a sheath, so a hollow cylinder, which has a area charge density coulombs per, that would be given in coulombs per square meter. Right. So if you're thinking about finding, the electric field using Gauss's law, you can't start with the equation that we derived for a cylinder with a volume charge density that we derived in class. So I would say what you should do is start from scratch. Right, so for the math part, as I said, this is always the same, right? So the math, you always end up with the flux being the electric field times the surface area of your Gaussian surface. So that's going to be nothing new. But for the physics, now, the question always is what's the enclosed charge? Right, so if you have a volume charge, Q enclosed is rho times the enclosed volume. But we don't have that in either case here. Right, here we have either a linear charge density, so you'd have lambda times the enclosed length, or an area charge density, so you'd have sigma times an enclosed area. Okay, so for each of those cases, you have to figure out how you would calculate based on that. So start with Gauss's law from scratch and do the physics side there. And so then, the question asks you what you would have to do to make the electric field zero if you're outside of both. So think about what that means for the total enclosed charge. Now, coincidentally, this is actually how coaxial cables are designed, where you have an inner part that carries a certain amount of charge or current, and an outer part that carries the opposite, so that or an opposite sign, so that you get no electric fields outside of your wire or your cable.